over here and make it negative. Yeah? And then I can make everything positive, because it's always more fun to be positive than negative, right? Yeah? Just a little pre-processing, we'll be happy. Notice that because we ordered our currents left to right, I1, I2, etc., that when we set up our equations, it also helps to put put these in ascending order. It'll be easier to put them in our matrix when we do that. You'll see, right? And then the same thing is true here, right? This guy's 8I1, right? Because the 5 and the 3 combine. And this is going to be 8I3, because again, a 5 and a 3 combine. And then I can put the 19 over here, make it negative, and then everything is positive because everybody wins. Yeah? I was just checking to see if you're... Yeah, it's a house of cards. If you mess that up, it's not like your answer looks like anything. It's just totally bizarre. Are we good so far? Yeah. So we made these equations. Now all I have to do is solve them simultaneously. We just have to solve them simultaneously, which just means setting up a giant matrix, right? Okay. So all the ones, I1, I2, I3, I4, set it up farther this way. Look at all the space we need. 1, 2, 3, 4, 5, right? And here's the answer. Right? So this is going to be B, this is going to be our matrix A. Okay? And then we've got I1 and I2. Okay? And then this guy is, if I put him in here, is 1, negative 1, negative 1, nothing, nothing. This guy, if I put this guy in there, it's going to be nothing, nothing, 1, negative 1, negative 1, right? And then if I put this guy in there, it's going to be 8, 11, and nothing, nothing, nothing. And then the answer is, the answer to this one is 0, right? These add up to 0, these add up to 0, but these add up to 19, right? Yeah? Yeah? Yeah, so these guys are coefficients, right? So the coefficient of this one is 1. Right, so I put that under the 1 column here because this is really for I1, all the coefficients of I1, I2. Yeah, I get that. Right? Right, so the 1 that's here goes here. The negative 1 for the 2 goes under the 2. The negative 1 for the 3 goes under the 3. And then there are no more coefficients. It's like times 0. I get that, but like, why do you even include those equations? Oh, we got it. We got 5 equations to solve a 5 by 5 system, right? Yeah. Okay, so then this guy again, we're 0, 0. Are we good so far? Are we good on how we're? Okay, so now we're going to go. This guy is 8 here, right? Nothing in I2, 8 in I3, 12 in I4, nothing there, and then the answer over here is 19, right? And then this guy is the same thing. It's 8, 0, 8. You'll see patterns, right? 8, 0, 8, and then nothing, and then 11, and that goes to 19, right? So this is a matrix. That's going to be B, right? And this guy is A. Right? And then, of course, this thing here, there's an equal sign in here, right? Okay? This is a matrix. There's a little bitty equal sign in there, right? And if this is A, then of course the answer matrix, this thing here, is equal to A inverse B, right? This guy B is the answers to the equations, I think. Is that right? Is that the right terminology? Is this one called the answer, and then this one, I don't know. I really don't know. Yeah, it's not the answers to our problems, it's the answers to these equations, but I don't know. Okay, I might be using the wrong terminology. So now what I think we should do is put this into our calculators, and let me show you that up here. So I'll stop filming this.
I